So hello coders, in this video we are gonna covering pointers and how the memory is allocated. So in this basic video, for example, we see that we assign a variable its value. For example, int a equal to 100. Suppose. So this is so what exactly happens over here? Well, we need to see that. So basically, the system contains a chunk of memory, a huge group of memory, which are divided into blocks. I'm just drawing this with my hand. So what happens after then? Okay, just so each block has got some address as if it has got a memory location, some address with which we can access it. This address is in the form of a number. Number might be integer or hexadecimal. In general, it is stored in the form of hexadecimal numbers. So for example, we are just assuming that this chunk of memory is called 200. The next one will be 201, then 202, and then 200, and so on. But in general, as we know that the integer in C requires either 2 bytes or 4 bytes depending upon the environment. So we're gonna make is we aren't gonna show each byte separately. Here's 2, so then we'll show 204, then 208, and so on. Okay. So what happens exactly? I'm gonna increase the font size as if when we write sorry so as if we write int a equal to 50 or anything, what happens? The compiler search for an empty memory. For example, these memories are empty. So what will happen if the compiler found this memory 200 for a? What will happen? The compiler will assign a name to this memory location 200 as if a, and put the value of what is the value of 50 in this is. So this line basically int a equal to 50 will search for memory. For example, it got the memory which is stored which is at address 200. Then it will assign it the variable a. Will give the name as a and assign the value 50 to it. So this is the concept. The next concept which we are gonna learn is basically the concept of pointers. For example, remember what we used to do while inputting or getting input from the user. We used to write as if int a, and to get it from the user, we could used to sign a percentage d comma m percent a. So what I told you was that we a is the variable name, but m percent a is the address of a. So while scanning or while taking the input, the values entered to the address of a. For example, in this case, the address of a is this one, is 200, sorry, and the value stored in the address of a, that is 50. Got my point? Okay, then what is a pointer? Pointer is basically a variable. Sorry, pointer is basically a variable which stores the address of another pointer. For example, in the syntax for that is an asterisk mark. For example, a pointer is written as int asterisk and then the variable ptr. So this is a pointer variable named ptr, which will store the address of another variable. For example, if for example we have written int a equal to 54 5, then the how will we store the address of a? Then int asterisk ptr equal to this address of operator and a. This address of operator is also called reference operator or ampersand. This is used to get the address of anything, anyone, any variable. So we are gonna test this right now. For here we have written int a 100, or we're gonna simply let's try to swap while getting the input. Then int asterisk ptr equal to address of a. That means this ptr contains and the address of a right now. Then if you wanna get the input percentage d, and we used to write percent a, but which is the address of a, but we have stored it in the variable PRT over here. So we are going to write PRT. It should do the same thing. We are just going to print to check if it is working. PRT. No, we are not going to write the PRT. We are going to see if it is stored in the variable A or not, because PRT must be pointing to A. So we're going to see if A contains that or not. So we are compiling. The computer asks for the value. I'm going to input 2 and 2 is printed. So A shows the variable. We use the PTR. So quite easy, right? The next concept which we are going to learn is the concept of dereferencing. The dereferencing, as if you want to get the value using the pointer. For example, we have got this PTR, and but we want to get the value. For example, we've got this address 204, but we want to see what is in that 204. If nothing is assigned, it will contain some garbage value, which means any random value. Otherwise, if we have stored something, it will contain that. Then how to do that? For that, we using this asterisk operator, also known as dereference operator or value at operator. So how I gonna use it? For example, the same thing, or this is a continuation of the previous one. If we have done this, int a equal to 5, int asterisk p equal to address of a, then if you want to print the value, just a second, if you want to print the value of a, either we can do this a, but we want to use the pointer to get this, then what do? We write value at ptr. This is the symbol. This is how we print what is inside this address. So we are going to check this also. Here it's the same thing, but instead of a, we are going value at prt, since the variable name is here is prt, and running 3, and 3 is printed. Cool. Yeah, okay then. So the next thing which I'm gonna try to show you is the addresses. Actually, the address is some any memory randomly from the computer. So the memory can be, here we have shown 200 and 204, but this can be anything. So we have different format specifiers to view that. In using percentage %d, we see only numbers. We can also use that. For example, in this example, if we write this, instead of value at PRT, we want to print what PRT exactly is. PRT contains the address, and we are for use asterisk to reference dereference it. That means the value at that address. But instead, we want to see what PRT exactly is. So we can also use that, but this is not advised to use percentage %d with PRT. Okay, but we're gonna see. Okay, we are still asking for inputs. So this is the address at which the variable a was stored. Okay, and we are gonna print, if we are printing the value, print the 4, the 4 is printed. So this is used to printing the value asterisk, and without asterisk it's just the address. To print the address, we have multiple formats where, for example, in x, sorry, percentage x or p, x and p stored shows it in hexadecimal format. For this, p will also show it in hexadecimal format. Sorry, 5. So this is the address at which this variable was stored at this moment of time. So how can we use it differently? Obviously, see how we can swap the variable names and its address via pointers, and how we can reference and dereference it. This is called referencing. The address of a is stored in the pointer, and this is called dereferencing because we are using the pointers to show the value in the variable. Okay. So what are the next concept are double pointers, which many find it confusing. So what a double pointer is, for that we need to understand that a is a variable which contains the value 5. PTR is a pointer variable which contains the address of a, and the address of a is containing the value a, which is 5. What is a double pointer? Since PTR is also a variable, it also will contain an address in which it is stored. For example, here if there might be this 212, in this the value address of a will be stored. The address of a, whatever it is, this might be stored, and this address of a, sorry, this address of a will point to this one, this 200, sorry, this 200. This is the address of a, and it will point to this memory block. So what we can do over here, since ptr is also a variable, we can use a pointer to that variable also, and that is called a double pointer. For example, int a equal to 20, int asterisk p, we are naming the pointer p this time, is equal to address of a, and int, since we are making storing an address of an address variable, that means an address of a pointer, we are going to use this double asterisk, which is called double pointer in general, equal to ampersand address of p. So what does this mean? So basically, as we pointed out, this 212, this might contain ptr or pa in this case. This is p. This p will be pointing to this 200 or this memory location. But this 212 is also a memory location. This will be pointed by q. So we are writing this q over here, whatever the memory location will be. This will contain 212, for instance. Then q will contain the address of p. This p will contain this p will contain the address of a, that is 200, sorry, and this 200 is containing the value 50. So how this works in programming, let's see. So in this case, how we generally print the values, as if we are going to say in here only. So printing the value a directly, it will be a, okay. The next, if you want to use this pointer, we'll use dereference p, okay. Printf, if we write dereference q, this means the value at q, the value at q is exactly the address of p, but we don't want the address of p, we want the address of a, then this will be double this. So this is how we can implement this. Also is using the syntax, it can be written as, if you want to just declare, we declare that int p and then p equal to address of a, because we have defined the p is a pointer, and then we just need p rather than asterisk p, okay. So we are gonna check what is done over here, okay. Okay, we are just gonna see this int a equal to 200, I suppose. Then int p equal to, sorry, pointer, if it's a pointer, it will be written as this, equal to address of a, and q equal to address of p. But this is be an error, because we want it is storing an address of and pointers, that's why it will be double asterisk. And printf percentage d space 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 percentage d space 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 and percentage d again, and you're gonna get a e this p and double q. This all should all print a, because they all are pointing to the variable a, 200, 200 and 200. So that's up for this video. Hope you liked it. Please ask any questions in the comment section below. Thank you.